Hey everybody, welcome to something a little bit different. This is a Math 100 or Math 180 exam from the University of British Columbia covering everything in about the first 15 lectures of the Calculus 1 series. So I thought I'd do one of their exams just to show you exactly what you'd see in a real class. And UBC is definitely not an easy school. Some of these questions are, they're not MIT level, but they were pretty close to what you'd see at an Ivy League university in the States. So, here we go. Let's start with question number 1. Simplify your answers as much as possible in questions 1 and 2. Note, this is going to be an incredibly long video, and I'm not going to write it super fast, so, try these questions as you see them and skip around, and if you know how to do a question, don't worry about watching the whole thing. So, the limit as x approaches negative 1 of this polynomial, so what do we do first? We should factor it. So we have the limit as x approaches negative 1 of x minus 2, x plus 1 over x minus 1, x plus 1 by factoring top and bottom, which we can then cancel our x plus 1's. So we're going to have the limit as x approaches negative 1 of x minus 2 over x minus 1, which is equivalent to saying negative 1 minus 2 over negative 1 minus 1, which is negative 3 over negative 2. So your answer is 3/2. Okay, next question. We see a square root in the numerator. So what we'll do is we will multiply the top and bottom by the reciprocal. So this is the square root of t squared plus 8, and then we're going to do plus 3 on the top and bottom. So we have the square root of t squared plus 8 plus 3. So now we will have the limit as t goes to 1 of, well, this becomes t squared plus 8 minus 9. So I'm actually just going to rewrite that right away as t squared minus 1 divided by, and then we'll leave the bottom the same. So we're not going to expand or simplify or anything on the bottom, because we want to find something that cancels. And if we factor the top, I'm going to put it in a nice red color. We get to use dark colors now because we're working on white. This will change to t minus 1, t plus 1. And then our t minus 1's will cancel. So we are going to get on top the limit as t goes to 1 of t plus 1 divided by the square root of t squared plus 8 plus 3. So now when we plug a 1 into this, we are going to get a much better number. So we're going to get 2 divided by, well, 1 squared plus 8 is 9. So the square root of 9 is 3 plus 3, which is 2 over 6, which is 1/3. So our answer is going to be 1/3. So again, these are all tricks in the first few videos of actually solving limits. So now if we go down to our third question, C, well, C, number 3, number 1C. No questions in math textbooks can just be one question with one part. That's unheard of. So we have the limit as x goes to 0 from the left of 1 over x minus 1 over the absolute value of x. And what I should say is that if x is less than 0, 1 over the absolute value of x is equivalent to saying negative 1 over x, because this x right here becomes negative x if x is less than 0. So with that being said, this question is the same thing as saying the limit as x goes to 0 from the left of 1 over x minus negative 1 over x. So it's the same thing as saying the limit as x goes to 0 from the left of, let's see, that's 1 over x plus 1 over x is 2 over x. And if you remember the graph of 1 over x, it looks something like this. And the 2 over x is just a scaled factor of 2. So this goes down to negative infinity. So our answer is going to be negative infinity. So there you have it. There's question 1, solving limits. Take a look at question 2 here. Find the derivative of x to the 4th plus x to the 7 over 2 divided by x squared. And it doesn't look like we need to use the definition of the derivative, so let's just rewrite this as x4 plus x to the 7 over 2 divided by x squared. Well, we could split this up into x4 over x2 plus x to the 7 over 2 divided by x squared. And then we just simplify each of these. So we end up with x squared plus x to the 3 over 2. And then we just take the derivative. So we have 2x plus 3 over 2 x to the 1/2. And they say simplify as far as possible. So I'm just going to take out a square root of x, and then we'll have 2 root x plus 3/2. But their answer key does not go that far for some strange reason, even though it says answers must be completely simplified. I don't know, it's a little bit of a lie there. But we have 2x plus 3/2 x to the 1/2. And I should mention right now, I do have an answer key open, so the answers in the end will be right, but the thought process may not be 100% on par. So, question B. If y is equal to x squared cos x, find the second derivative y double prime. So, this is just using the product rule. So y is equal to x squared cos x. So y prime is going to be the derivative of the first term. It's just y regular prime. So this will be 2x times the second term plus the derivative of the first term times the second term. So x squared times minus sine x. So I'm just going to bring out the minus sign and subtract it. And then for y double prime, we do the same thing. So we're going to have 2 cosine x. I'm going to do these in different colors. We're going to have 2 cosine x minus 2x sine x for the first term, and the second term is going to be minus 2x sine x plus x squared cosine x. And now we have to represent it in this form, px sine x plus qx cos x. This just means that we have to factor out all the like terms. So we're going to get 2 cos x plus x squared cos x. This is a terrible color. I will not use pink. I'm so used to going to all the dark colors. I mean all the light colors for the black background. And, okay. So it's 2 cos x minus x squared cos x. I totally forgot to distribute there. And then we're going to have minus 2x sine x, and then minus another 2x sine x. So if we follow our rules here, this is going to be minus 4x sine x. And then we're going to have to add, actually, we'll subtract x squared plus 2 times cosine of x. And this is the same thing as saying 2 minus x squared. It doesn't necessarily make a difference. So our final answer here is going to be negative 4x sine x, and I'll write it the same way they have in their answer key, plus 2 minus x squared cosine of x. Okay, if y is equal to x sine of root x plus x, find the derivative of that equation. Okay, so we have y is equal to x sine of root x plus x. So we have some product rules and some chain rules. Product rule is easy. We take the derivative of the first and leave the second alone. And then we add x times, well, we have cosine of whatever's in the middle. And then we have to multiply it by the derivative of the inside, which is going to be 1 over 2 root x plus 1. So, at this point, we don't really need to simplify anything. If anything, it's just normal to bring this out front and multiply it by x. But that is about the only thing that needs to be changed here. So, I'll write it out before putting it in the answer box. So, sine of root x plus, well, x over 2 root x is the same thing as saying root x over 2 plus x multiplied by the cosine of root x plus x. And I'm just going to put an arrow there because I don't think that would fit nicely in the box. Okay, this question is kind of tricky, this next one. So we'll go over this. F is a function that satisfies f prime of e is equal to e. Let g of x equal f of e to the x squared. Find g prime of 1. Okay, so here's what we have to think. We're not given f of x. So we're not given f of x. So we don't know what that is. But we're given f of e to the x squared, and we know the chain rule. So we know g of x is equal to this. So g prime of x is going to equal the derivative of e to the x squared times something times our chain rule. So then we have to look at this derivative right here, x squared. So this will be times 2x. And because we're given the function and what's inside the function, wherever we have an x in the regular equation, we have to replace it with e to the x squared. Which means we also have to take the derivative of e to the x squared in here, and that is just going to be itself, e to the x squared. Well, it's going to be this whole thing right here, but this is our chain rule. So this is our f prime of x, and this is our f of x here, or f of u, however you want to write it. So this is the chain rule. This is not, this is definitely not an easy question for the first time you see this. And we have to find g prime of 1, so let's replace all these things with 1. So it's going to be f prime of e to the 1 squared, which is e, times, well, e to the 1 is e, times 2 times 1 is 2. So we have 2 times e, and we know f prime of e is equal to e. So we're going to have 2e, which is the same thing as saying 2e squared. Again, not a very easy problem. That's why it's only worth 3 marks. These are one of the questions that separate the A pluses from the A's. And a lot of people in university, a lot of professors anyhow, these are the big questions because not everybody can get an A plus. In fact, I'd say even getting an A minus on this exam at UBC, which is 80% in their department, they have a strict grading department or strict grading scale, which is a little weird to me, but yeah, it's not the easiest thing to even get an A minus on this. So when you're doing the questions on your own, you can't get these right. Don't feel bad. It's good practice. Okay. Question number 3. Let f of x equal this thing and find the horizontal asymptotes. So what are horizontal asymptotes? These are the asymptotes that we find when we take the limit as x goes to infinity of x squared plus 1 over 3x plus 5, and the limit as x goes to negative infinity of this same thing. So when we look at limits from infinity, we want to divide by the leading term in the numerator. So the leading term is the square root of x squared. So we're going to divide both the top and bottom by the square root of x squared. So we're going to take this divided by root of x squared, and we're going to take the bottom, and we'll just divide it by x because it's the same thing. So what we're going to get is we're going to get the limit as x goes to infinity of, really it's going to be root 1 over 3, because the other terms will go to 0. So we're going to have the same thing for negative infinity. And this is going to end up being root 1 over 3, but it's going to be negative because we're dealing with a negative infinity. In fact, I'm trying to figure out what weird thing I am doing here. Yes, so in the bottom, this is a negative infinity because the square root of x squared implies that x is negative infinity, while in the top, the square root of x squared implies that x is positive. So, what we have is we don't have anything to plug x into, and we're just going to be left with these answers. So, y is equal to 1/3 and y is equal to negative 1/3 are horizontal asymptotes, because we just look at where x goes to infinity and x goes to negative infinity. And if it's a value, that means it's never going to touch it. Now, keeping with this fashion of finding horizontal asymptotes, let's find some vertical asymptotes. So determine the vertical asymptotes of the graph y is equal to f of x. For each vertical asymptote, x equals a, determine whether each side of the one-sided limits equals infinity or negative infinity. So we have our question here, which I'll rewrite our equation. Square root of x squared plus 1 divided by 3x plus 5. So a vertical asymptote happens when the bottom is equal to 0. So we'll solve this. 3x is equal to negative 5, x is equal to negative 5/3. So we need to take the limit as x approaches negative 5/3 from the right of this equation. And to do this, we're just going to take a look at if the top is positive and the bottom is positive or not. So when it comes from the right, the bottom is going to be negative, and the top is going to be positive. So this is going to equal positive, wait, hold on. The bottom would be positive, sorry, and the top would be positive. So this will be infinity, and the limit as x approaches negative 5/3 from the left is going to equal, well, here the top will still be positive because we're dealing with an x squared, and the bottom will be negative, so this will be negative infinity. So as it approaches from the left, it'll be negative infinity, and from the right, it'll be positive infinity. The reason they're looking for specifically each of the one-sided limits is because they know that the limit itself does not exist. So that is why they're asking about that. So again, if you're confused, I'm just checking the signs. You can put in these values. So you can put in a value incredibly close to this. So say negative 1.67, and you could try out that value, and from here you could try a negative 1.65, plug it in and see what you get. But just like in previous problems with the exact same thing, you don't necessarily want to put in values. You just kind of want to see what happens as you get closer and closer by putting in negatives and positives, because you can figure out whether it's going to be slightly negative or slightly positive, and then just divide and see what you get. So our answers, there's no answer box for this question. It's kind of weird. It's kind of weird there's no answer box for this question, but all right. Question number 4. I like these questions. Almost every midterm I've ever looked at for Calculus 1 has this question. Find the values of a and b for which f is continuous at x equals 1 and x is equal to 2. So, what does it mean to be continuous? To be continuous at x equals 1, it means the limit as x goes to 1 of f of x is equal to f of 1, and the limit as x goes to 2 of f of x is equal to f of 2. So, let's do this. The limit as x approaches 1. Okay, so the limit as x approaches 1 from the left, if we take a look at 1 from the left, here's the equation of 1 from the left, of x squared plus b is going to be equal to the limit as x goes to 1 from the right, which is this equation right here, of ax plus b. And this is going to be equal to f of 1, which is going to be the same thing as x going to 1 from the right, because this is greater than or equal to. So we just need to check out these two things right here. So let's plug 1 in to our equation here. one from the left is going to be 1 plus b is going to equal a plus b. We can subtract b from both sides, so we're going to get a is equal to 1. So for our answer here, I'm going to put a equals 1 in the box, even though we're not entirely sure, because we might find a contradiction if something goes terribly wrong. Okay, and for the second one, we need to find, oh god, that's a disgusting light green. The limit as x goes to 2 from the left, well, 2 from the left is going to be ax plus b. This equation has to be equal to the limit as x goes to 2 from the right, which is this equation right here, and this will be 5x minus 3. So let's plug our values in here. We get a times 2 plus b is equal to, that'll be 10 minus 3, which is 7. So we're going to have 2a plus b is equal to 7. We know that a is equal to 1 based on our answer up here. So this is 2 plus b is equal to 7. So b is going to equal 5. And from this, we don't have any contradictions. And now these two definitions are satisfied. So we can safely say that these two are going to be continuous now. So yeah, that was question 4. 6 marks. Probably the easiest 6 marks on this test, honestly, if you just know the definitions of continuity, because the algebra really wasn't too bad. Okay, question number 5. Prove that the equation x cubed minus 3x plus 1 equals 0 has at least 2 positive real solutions. Okay, so we want to prove something has 2 positive real solutions, which means that we need to bring something out called the intermediate value theorem. And I will rewrite this theorem out for you. It might not be the same way that you've seen it, because, well, this is just coming right out of my mind right now. If f of a is less than f of b, or f of b is greater than f of a, then there exists a c between a and b such that f of c is equal to 0. So what this states is that if the endpoints are different, then there's going to be, if f of a is less than f of b, sorry, this should be different. If f of a is less than 0 and f of b is greater than 0, then there exists a c between a and b such that f of c is equal to 0. Okay, again, this is coming right from my brain, so a little mistake there, but this is the intermediate value theorem. So we want to find values where f goes below a, or f goes below 0, and f goes above 0, and then f goes below 0 again. And we also need to state that by polynomials, we know that all polynomials are continuous. So using these two theorems, we can now find real roots. So let's try some values. F of 0, f of 1, f of 2. These are always good values to start out with. So let's just plug them into our equation. We're going to get 0 minus 3 times 0 plus 1 is 1. Again, I keep going for the ugly green. So that's going to be 1. F of 1 is going to be 1 minus 3 plus 1, which is negative 1. And f of 2 is going to be 8 minus 6 plus 1, which is 3. So if we plug our little number line in here, this is going to be 0, it's going to be 1, it's going to be 2. And we do a little graph here. Of course, this is going to be completely accurate. But at 0, it's equal to 1. At 1, it's equal to negative 1. And at 2, it's equal to 3. If we just draw our lines, we know that we're going to have a root here and here. So we don't know where it is, but we can say that there is a root in 0, 1, and there's a root in 1, 2. And we could shrink our intervals, but it's not necessary since we're not saying prove that there's a root to at least 0.1 decimal places or anything. We're just saying that it has at least two positive solutions, and those are two solutions. So again, it's one of those things you just have to remember the theorem, and once you remember the theorem, everything goes pretty well. The question is not trying to trick you. This question, I didn't teach it ever, and I'm assuming it's something really unique to UBC's course because most other exams I've seen don't have this in there. This is like a pre-calculus thing, but I don't know. This was never explicitly taught to me, so I had to figure out what was going on for a second. But really, when you look at it, this question isn't too bad, so I'm still going to do this for you. Find the points on the curve y equals x squared plus 6 such that the tangent lines to the curve at these points pass through the point 2, 1. So when they say tangent line, they mean they want the derivative of this because it's the slope. So let's just take the derivative right away. Y prime is equal to 2x. And we want to find points such that the tangent lines pass through 2, 1. So what we're going to need is we're going to need a point slope form. So y minus y0 is equal to m times x minus x0. And we also need to realize that this point is going to be at point x f of x, because this is how points are listed. Sometimes we write this as xy, but x f of x is the same thing. So we're going to replace this with the letter a. So it's going to be at a, and f of a is going to be a squared plus 6. And these are going to be our initial values for x0 and y0. So let's plug some of these things in. This is going to be y minus a squared plus 6 is going to be equal to, well, our slope here, this is our slope, this is m. We have to take the derivative to find the slope. So this is going to be 2a times x minus our initial x is going to be a. So now let's just do some simplifying here. We have y minus a squared minus 6 is equal to 2ax minus a squared. Alright, and now what we want to do is we want to get this between the points 2 and 1. So we're actually going to plug those values in right now. So we have 1 minus a squared minus 6 is equal to 2a times 2 minus a squared. So we're going to get negative a squared minus 5 is equal to 4a minus a squared. So now what we can do is we can bring stuff over to one side here. So this is going to be 4a plus 5. We have a negative a squared and a negative a squared. This is a bit of a problem. We have minus 2a squared. What did I do wrong here when I distributed here? I'll do all my corrections in green. Should be 2a squared. So minus 2a squared minus 2a squared. So when we bring this over to the left side, we are going to have a squared is equal to 4a plus 5. So we'll rewrite this nicely, which will be a squared minus 4a plus 5 is equal to 0. Let's factor this out. This is a plus 5, a minus, whoa, okay, again, weird things are happening here. A squared minus 4a minus 5. A squared, yes, should be minus 5, sorry. And this is going to be a minus 5, a plus 1, which implies that a is equal to 5 and a is equal to negative 1. So we're going to take these two values and we plug them back up into this equation. So we're going to get the values negative 1. So negative 1 and negative 1 squared plus 6 is 7. and we're going to get 5, and 5 squared is 25 plus 6 is 31. So our two answers are going to be negative 1, 7, and 5, 31. And this question right here is one of the questions that separates the B's from the A's, because this right here is worth a significant amount of marks, and people who get this question right are probably A students. People who get this question wrong are probably B students, because this is one of those things that is conceptual, because it says find tangent lines. You're not told to find this, to find the derivative, but you have to realize that the tangent line is a slope, which is a derivative. You have to pull out the point slope form to solve, and you also have to recognize that points on a graph can be written in this style, which translates down to this, and then you have to solve. So it's a big question. There's a lot of stuff to do in this question. Okay, and we're finally going to move on to the final page of the exam, which is finding a derivative using the definition of a derivative, and then the hardest question on the exam, which I will go through very slowly. Okay, so we just have to find this using the definition of a derivative. So it's the same thing as saying the limit as h goes to 0 of f of x plus h minus f of x over h. So let's just plug everything in. Limit as h goes to 0 of 1 over 1 minus x plus h minus 1 over 1 minus x, all divided by h. And at this point, what we do is we simplify the top. So we multiply. So we're going to find common denominators and fix that up a little bit. So we're going to get 1 minus x minus 1 minus x plus h, all over common denominators, h, 1 minus x, 1 minus x plus h. And what we can do now is we can cancel some things out. And the things we can cancel are going to be this 1 minus x and this 1 minus x. So this thing right here is the same thing as 1 minus x minus h. We're just canceling this portion out. So on the top, we are going to be left with minus negative h, which is h over h times 1 minus x plus h. And what you can see here is that these h's are also going to cancel. So this question is going to evolve into the limit as h goes to 0 of 1 over 1 minus x plus h, which is the same thing as 1 over 1 minus x. And this would be the end result, except for the fact that something really weird is going on. I was not supposed to cancel these. This 1 minus x stays. And okay, I was jumping ahead of myself. So they don't cancel because it's not, sorry, this is 1 minus x minus 1 minus x, sorry, 1 plus x plus h. So you have a 1 and a minus 1 that cancel, and a minus x and an x that cancel. So you're left with h over all this stuff. The h's then cancel, and then the h goes to 0. So you have 1 over 1 minus x plus h times 1 minus x. So this ends up as 1 over 1 minus x squared. And that's one of those examples where I just do things a little bit too quickly and get a little confused. So this is the solution to this question. Terribly sorry for the error there. And in this next one, which is a lot harder, I will do my best to avoid all errors here. So determine whether this function is differentiable at x equals 0. Question is, what does it mean to be differentiable? This just means that f prime, and we're going to do this at 0, so f prime of 0 has to be equal to the limit as h goes to 0 of f of 0 plus h minus f of 0 all divided by h. This is the same thing as the definition of the derivative. We just replaced x with 0. So let's take the limit as h goes to 0 from the left. What is this going to be? Actually, you know what, first, let's simplify things a little bit. We don't need to do this. Let's find f prime of 0 and see if we can cancel it out. So f prime of 0 is going to use this equation. It is 4 times 0 squared minus 0, which is 0. So, actually, when we simplify a lot of things here, this is going to be the limit as h goes to 0 of f of h over h. Because this f of 0 cancels, 0 plus h is the same as h, and we're dividing by h. So this actually makes things a lot easier to find. So let's take the limit as h goes to 0 from the right of, well, from the right, it's going to be x cubed, sorry, this will be h cubed sine of 1 over h divided by h, which is the same thing as the limit as h goes to 0 from the right of h squared sine 1 over h. And do you remember how to find this? Well, this is the squeeze theorem. So we have to squeeze this. So we know sine of 1 over h is going to be between negative 1 and 1. So we multiply both sides by h squared. So we get h squared sine 1 over h is going to be less than or equal to h squared. And then what we do is we take the outside and we put them to 0. And we see what happens. So 0 on the outside is going to be less than the limit as h goes to 0 of h squared sine 1 over h, which is going to be less than 0. So we know that this right here is exactly 0 because we've squeezed it. So the limit, I'll write this in a box up here, the limit as h goes to 0 from the right of f of h over h is equal to 0. And the limit as h goes to 0 from the left of f of h over h, well, if we go from the left, we are then going to do, you know what? Here's the one mistake I made. This is from the left, and now we're going to do the right. I've been getting my lefts and rights mixed up. Okay, so f of h over h is going to be 4h squared minus h over h, which is the same thing as 4h minus 1. If we plug h equals 0 in here, we're going to get 0 minus 1, which is equal to negative 1. So from the right, it's going to be equal to negative 1. And because these don't equal the same thing, the limit does not exist. So the lim does not exist. Therefore, what do we know there? It can't be differentiable. And that is the unfortunate truth. So there's 3 marks. This is definitely an A+ from A's question, because probably, honestly, the second hardest or hardest question in this exam. In fact, if I have to take a look at all these questions, the things I expect at any university, question 1, definitely you should be getting 9 out of 9 on question 1, because that stuff was just taking straight limits. This one right here, 2A, if you don't get 3 out of 3 on that, you have missed something in my lectures and anyone's lectures, and you need to go back and review that stuff. 3, I can see 2 out of 3 for this in case you have an arithmetic error, but for the most part you should be getting this question right. Arithmetic errors are probably very common. C, you could make a mistake at this point right here, 1 over 2 root x, and if you don't simplify, you might be getting a mark off here. So 2 out of 3 would be acceptable there. In D, Yeah, I'd say the average for this question was probably roughly 0.5 out of 3 on this question, if I had to take a guess. Because I don't see people being able to do this without knowing an excessive knowledge of the theory. And in a Calc 1 course, your focus is not theory. So that whole section, probably 7.5 out of 12 would be totally expected. So you should be doing better than this. If you're doing better than 7.5 out of 12 on there, good for you. You're ahead of the curve. Question number 3, horizontal and vertical asymptotes. For horizontal asymptotes, the only thing I see probably causing trouble is that, but I would expect at least 2 out of 4 for the first one. If you can't get the first one, you need to review limits at infinity. For the vertical asymptotes, this is one of those things that just figuring out what to do here, actually this part right here, this would be 1 mark, this would be 1 mark, this would be 1 mark. You might be having troubles on the right side, but at the same time, you should be getting, I would say, 3 out of 3 on this question. So, question number 4 or 3, I believe, you should be getting at least 5 out of 7 or better on this stuff. Question number 4, let A and B be constants with continuity? Ideally, you should be getting 6 out of 6. I don't think there's any way not to get 6 out of 6. If you know what you're doing, you're going to get a 6. If you don't know what you're doing, you're going to get partial marks for where you screwed up. So if you have a range between 0 and 6, I would say if you know what you're doing, you should be getting 6. If not, then if you got anything less than 6, you either made A, one really small arithmetic error, or B, you don't know what you're doing. So that is 1. Question number 5. So this is a mark. This is a mark. And each one of these roots are a mark. So what I expect, 3 out of 4 or greater. Why do I expect 3 out of 4? Because I have a huge feeling that people totally forgot to write that down. And this is probably one of the things you forgot to write down. So 3 out of 4 better on that one. Find the points on the curve such that blah, 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 blah. Tangent lines. Honestly, I expect most people to get 0 to 6. That's one of those things that I expect everyone to get wrong. At least where I went and where most of you guys are doing stuff if you haven't done this question before. But yeah, 0 to 6 seems plausible. If you did get over 4 to 6 on this, good job. That is impressive. And for these last 2 questions, this one I didn't do very good on. I did not do very good on when explaining this to you because I made a couple mistakes. Realistically though, you should do better than me and get 3 out of 3 on this one. And then this last question here, honestly, I expect probably 2 out of 3. Because here's how the marks would be broken down. In fact, I have a nice little space for all these marks here. This is worth 1 mark here, that's worth 1 mark, and this conclusion is worth 1 mark. And what I do expect, actually I need to make this a 1 out of 3, because I do expect everyone should be able to get this one. 0 from the right. If it's 0 from the left, if you remember squeeze theorem, you're good here, and if you do both of them, you should be able to get the last one. So you're either going to get 1 out of 3, or you're going to get 3 out of 3. There's almost no case where you're going to get 2 out of 3, because that's a little weird to be able to get both the limits, but not be able to get the answer right. And you're not going to get marks for this if you don't have the other 2 even answered correctly, because you can't make a conclusion. So there's a midterm for you. I have another midterm coming up. I don't know when I'm going to do it. I'll probably do more videos, finish up the Calculus 1 series, and then put another midterm out, or final, do that, and then we'll see a couple more midterms for different stages in calculus. So hopefully you found this helpful. This is midterm 1. If you want to take a look at other midterms, UBC has some good midterms. Of course, there's always MIT, which is a little bit harder. And of course, your local universities, you can always Google their pages, see if you can find old exams, and if you want a specific exam done, don't be afraid to tell me in the comments, and I will check it out, and if it's a good exam, and there's some good stuff to learn from it, we'll do it and put it on the channel, because I think the best way to learn what you need to know is to try a bunch of practice midterms, see what you can't get, learn it, and try again. So, it's a 45-minute video. I won't take up any more of your time, but that's exactly the amount of time you'd be given to write this. So, there you go. 45 minutes to write that. And if you're writing it any slower than I just did, you also need to work on your timing, and you need to practice questions more, because you need to be doing them faster than this. So, see you guys next time.